So since I assume that means nobody has any questions from the homework since they didn't do any. Cough, cough, hint, hint, yell, yell. Alright, so I guess that really does mean nobody has questions. Okay, so we're going to look at another example. We'll do some examples today, and then you hopefully will get a little bit better handle on what we are doing here. Alright, so we're looking at, let's see, so they want us to prove that 3n is less than 3n plus 1 for the natural numbers. Okay. So the first things first on this problem, we have to know what a natural number is. Who remembers what a natural number is? Nobody knows what a natural number is? Come on. Okay, I guess I'll tell you since nobody knows. Your natural numbers are your counting numbers, 1, 2, 3, 4, 5, etc. On and on forever and ever. So basically they're telling us not to do decimals, no doing negative numbers, no zero, stuff like that, to make it easy on us. So I've written the steps on the top right of the board so we know what we're doing for each problem. This is the 3 steps for your mathematical induction. Step 1, we're going to show that the n equals 1 case is true. So for 1, plug in 1. Is 3 to the first true? So very basic step, pretty easy to do, no complications. I will give you the hint that this will be true for all of your cases. We're not going to give you problems you can't do. So you plug in 1 for n. Is 3 to the first less than 3 to 1 plus 1? Yes, 3 is less than 9. That is true. Step 2, you assume it to be true for n equals k. So basically we write the word assume. The word assume is very important. And then replace your n's with k's. Pretty sure I have faith that everybody can do step 1 and 2. Does anybody feel they can't do step 1 and 2? Awesome, everybody can do step 1 and 2. Step 3 is where you have the hard part. That is where all the work is in these problems. We are going to prove the k plus first case. So what does that mean to do? What am I going to do for line 3 if I'm looking at the k plus first case? Somebody help us out here. What are we going to do?
Are you going to take like the natural log of it to get the k's out of the exponents?
Nope. I mean, it's a possibility, but that's not what I would do first anyway. The first thing is, we have to ask ourselves, what is the k plus first case? If you look back at your original problem, this is the nth case, so I need the k plus first case. So we can replace all of our n's with k plus 1s. 3 to the k plus 1 plus 1. So that is what I am trying to prove. Somehow we're going to need to use our assumption that we did in step 2 to help us to prove that. So we have to manipulate this some way, some form to get the above case, somehow, that assumption case. So this is where your exponent rules will come into play on this type of problem where you have exponents. So as Madison said, sometimes you will do ln's and logs and things like that. Other times you will not. So this one's actually a lot easier if we remember our exponent rules. So I am trying to get 3 to the k and 3 to the k plus 1. Well, that means on the left-hand side, I need to change this 3 to the k plus 1 into 3 to the k somehow. Is there any way we can do that? Apparently Olivia just doesn't know. This is where we have to remember our exponent rules from algebra. I think you learned them in algebra 1, maybe algebra 2. So we have to remember that if you were adding exponents like that, you can switch them to multiplication. So 3 to the k plus 1 can turn into 3 to the k times 3 to the first. And 3 to the k plus 1 can turn into 3 to the k plus 1 times 3. Does everybody see how I did that? Okay, well at that point the rest of the problem tends to be pretty easy because I can divide both sides by 3 and you get 3 to the k is less than 3 to the k plus 1, which is true by 2. Therefore, it's true. So in case you've never seen the 3 dots before, 3 dots mean therefore, so therefore 3 to the n is less than 3 to the n plus 1. For natural numbers, by principle of mathematical induction. Any questions on what I did? Who fell asleep while I did what I did because it was so boring?
I did not. I'm a good student.
I fell asleep.
Alright, so what we're going to do today for the rest of it, because that's, like I said, pretty much we covered all of mathematical induction yesterday. We're going to work some problems. So somebody pick one from number 9 through 20.
17.
Okay. So 17 and then 14 possibly. Alright, so 17, 1 plus 3 plus 5, 2n minus 1. I believe that was equal to n squared. Alright, so that is number 17. They're asking us to prove that by mathematical induction. So the first thing is we have to figure out what are we looking at to prove, in other words. So what is the left-hand side, the 1 plus 3 plus 5 plus dot dot dot? What is that? Actually, what is that? That is arithmetic, yes, but that's a little too specific of what I'm looking for. I don't want to know what kind of series. I don't care what that is, but I want to know what is that. So what is the left-hand side? There's a couple different words we have that we could use for that. They're phrases, I guess. What is it called when you add a whole bunch of things up?
A sum.
Okay, let's use a little bit better word since we're in higher level mathematics now instead of just a sum.
Summation, partial sum.
Okay, both of those are two exactly the things I was looking for. We can call it a summation, we can call it a partial sum, or we can call it a series. Don't forget that is our new word that we've looked at. So you've heard sum before, which is just a short version of summation, but series is what our sections, that's the new word that we've been calling. Remember, we have sequences and series. This is a series, so it's a partial sum or a summation. Basically, the question is asking, is S sub n equal to n squared? Can we prove that using mathematical induction? So let's go for it. Step 1, n equals 1 is true. So we're asking, does S sub 1 equal 1 squared? Well, what is S sub 1 according to our summation? Well, n equals 1 is the first case. So S sub 1, our partial sum, is 1. Does 1 equal 1? Check. Great. 2. 2 is always the same. You assume S sub k is equal to k squared. You replace your n's with k's for your second step, your assumption. And then step 3, we are trying to prove that S sub k plus 1 is equal to k plus 1 squared. So we just replace our k's or the n's from the original problem with k plus 1s. Does everybody see what I did? Anybody have any questions on what I did so far? Because I haven't done much of the actual problem yet.
Wait, so you just plugged k into n in the equation?
For step 2, yes. That's what you're assuming. You're
I mean,
assuming
step
that to be
3.
true. Step 3, I plugged k plus 1 in.
Oh, okay. Wait, why?
Because that's the next case. So if k is the case we're currently on, what's the next one?
Oh, okay, got you.
So, and like we talked about yesterday, remember, we've proved it true for the first case. Yes, everybody understands that's what number 1 is, I hope. Well, if I have proved it, if what actually ends up happening in 2 and 3 is I am proving it for the next case. Well, if 1 is true, what's the next case? Okay. If 1 is true, what is the next case?
1 plus 1.
What?
Well, something like that, right?
Mm-mm. What comes after 1?
2.
2.
2.
So if I proved it for the first case, 1, that means the second case is true. Well, if the second case is true and I've proved it for the next case, what's the next case?
3.
And then if I proved it for 3, what's the next case after that? Okay.
4.
So hopefully people are picking up on what I'm saying. So what the whole mathematical induction is, step 1, you're proving it true for the first case. 2 and 3 combining together to prove it for the next case. Well, if 1 is true and the next case is true, then 2 is true. Well, if 2 is true in the next case, then 3. 3 and then 4, 4 and then 5, 5 and then 6, so on and so forth forever and ever. That's how this mathematical induction works. So you prove it true for the first case, and then you show it's true for the next case, which is the k plus 1 idea. K plus 1 represents the next case. And then if you can prove it for the next case, like I said, if 1 is true, then 2 is true. If 2 is true, then 3 is true. If 3 is true, then 4 is true, etc., on and on. And that gets you through to every number. So we've got to ask ourselves, how do we show this? Well, the first thing is, we probably should write out, since we're doing a sum, what is S sub k plus 1? Well, if we go back up to our formula up here, that is 1 plus 3 plus 5 plus ... plus 2k minus 1, which is this one. What is the next case after 2n minus 1?
Wouldn't
2n.
you just do plus 1? Like add another one?
No, gotta be careful. So the next case will be 2k plus 1 minus 1. So every time, remember the variable is n, so I replace it with k for the kth case. If I want the next case, that's the k plus first case. So you replace your variable with k plus 1. So everybody see how I got that next term now?
I'm confused where you got the first 2k minus 1.
I replaced, so this is the first n terms at the top. So I replace n with k because I'm dealing with k's now instead of n's. That's the only difference. Then the next number after that one, I replace the variable with k plus 1.
Wait, I thought the series ends there.
The s sub n does, or s sub k does, but what series am I on?
Oh.
I'm on the
k plus 1.
I'm on the k plus first, so I got to add that extra term. So this is the first k terms. This is that next k plus first term. Okay. Any other questions? Please do ask them. That's the whole point of this today, is going over problems so you see where things come from and everything. Okay. Now the whole reason for doing this, because this is going to be a very common theme for these problems. What is that? 1 plus 3 plus 5 plus dot 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 2k minus 1. What's another way of expressing that?
S sub k?
Correct. That is our assumption. That is s sub k. That is the first k terms, and I'm adding them up. So that is s sub k. So this is s sub k. Plus, I'm going to go ahead and simplify this out a little bit. So this is 2k plus 1. What is s sub k, though? Based on my assumption, s sub k is equal to k squared. That is why we needed this line 2 right here, is so that when we get there, we can plug that in, because we say, hey, I'm going to tell you this is true. I'm assuming this to be true, so that I can use it in my line 3, or in my step 3. Well, I'm almost there. What do I need this to end up equaling? So what's the whole point of this? What should it equal?
K squared.
Ooh, no. Close.
K plus 1 squared?
Correct. Remember, I'm trying to prove line 3. I've got the left-hand side what I need it to be. That's fine. So I need to get this right-hand side equal to k plus 1 squared. Does this equal k plus 1 squared?
Yeah.
And I'm going to hope that everybody realizes that, yes, that is a perfect square. You can factor it, and you'll get k plus 1 squared. We got the result we wanted. We're done.
So how do you write that? Like in the previous one, you did the little dot things.
So, therefore, s sub n equals n squared. I don't think they say natural numbers or anything, but by PMI. And PMI, again, is make sure it's the principle of mathematical induction. It is natural numbers, so they said natural numbers, but you can just say Sn equals n squared by PMI. See number, what was that, 17? So I'll give you their exact wording if they give a statement. Hold on. 17. They don't write it as Sn. They just write 1 plus 3 plus 5 dot 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 equals n squared. Is true for all natural numbers by principle of mathematical induction. I don't think she's gonna count you off if you don't really necessarily write out all the wording and stuff like that. If you write what I have on the board, if she doesn't give you full credit, I would be very surprised, because that is exactly how I would write it if I was writing up a proof. Alright. Questions on what I did on that one before I do another one? Alright, then I will do number 14. It looks like that was what Miss Olivia picked. Nope, Olivia's typing. Okay. Just want to make sure I didn't erase it while you were still looking at something or had a question. Alright, number 14. 14, 10, 17, 24, 7n plus 3. Equals n 7n plus 13 over 2. So this one's going to involve a little more algebra, but not a tremendous amount more. Okay, what's step 1? Somebody walk me through this.
Make it, see if n equals 1 is true.
Okay, so does 10 equal 1 times 7 plus 13 over 2? 10 is equal to 20 over 2. 10 equals 10. True. All right, somebody else, give me step 2. Oh, come on, step 2 is the easiest one.
Assume that n equals k. So put, replace those n's with k's.
Yeah. So we're going to assume s sub k, which is equal to 10, plus 17, plus 24, plus dot dot dot, plus 7k plus 3 is equal to k, 7k plus 13 over 2.
Wait, why are you using the 10? I'm confused.
What do you mean, why am I using the 10?
Like, is it because it's the first problem? I'm confused.
The
Because-
first term, right? You have to use.
Yeah, so the sum of
The
k
first
terms is the first k terms. So 10 plus 17 plus 24. Why would I leave off the 10?
I was just confused why you were using that to be equal.
Wait, I have a question. On the first line, on the right side of the equation, it's n parentheses 7n plus 3
13.
over 2 plus 13.
Yes.
Okay.
And your question is on line 1, Madison, correct? Up here at the top? Not.
Yes.
Okay, see, I was confused. I was already on step 2. So what is the first term? The first term
So
is
wait,
10.
we used the first term. Okay, I didn't know we used the
So-
first term.
Yes, you're using s sub 1 is equal to that right there. S sub 1, the sum of the first terms is just 10 because it's only one term.
Ethan.
Okay. Any other questions? Again, please ask. That's the whole point of all this stuff. This stuff's really not that hard with the cases that we're doing, but you have to understand where each piece comes from and where, like, what you're doing with it.
Just, is there a way to know why they put 13 there instead of
Because they figured out the formula.
7n plus 3?
It has nothing to do with this. This is the formula. They've figured it out already.
Okay.
They're just telling you, hey, this equals this. Prove it to be true.
Okay.
They've already figured out what it is. We're just we're verifying it, really. So that's what's going on. That's fine. Thank you, Miss Abby. And we're doing number 14 currently from the homework. So is everybody caught up to step 1 and 2? Are we okay with those before I move on to step 3? Okay, so step 3. What is step 3?
You replace k's with k plus 1.
Right. So I don't have to necessarily do it in here. You can if you want to. I do it like this on my first line, though. So you don't have to replace k plus 1 plus 13 over 2. So my first line, that's how I write it out. All right, s sub k plus 1. That's what I'm trying to prove. So I put that on my first line every single time. So So that gives me an idea of once I get there, I'm done. So some people like to put the word prove in front of this and stuff like that so they know what they're doing. So this is what I'm proving. That's the whole goal, is to get to there. So that's why I put that on my first line, so it gives me an idea of what I'm doing, where I'm trying to go, etc. So then I start with sk plus 1, which is my left-hand side, and I try to reach the right-hand side. That's the whole goal. So what does s sub k plus 1 equal? And don't tell me this thing up here, because that's where we've got to get to in the end. What is s k plus 1?
Well, the first part is S sub k, and then, yeah,
Okay,
you have to,
so, but we can't skip steps. We got to write everything out. So sk plus 1 is the sum of the first k plus 1 terms. Well, according to my original, that is equal to 10 plus 17 plus 24 plus dot dot dot. And then instead of an n, I'm going to put a k. So 7k plus 3. What is this that I have written out there? So if I go
Are you
from,
asking what that is?
yes, from 10 to 7k plus 3, what is that?
A series?
But what kind of series is this? Very specifically for this problem.
S sub k.
This is the first k term, so s sub k. I need k plus 1. So what else do I need to add on here to the end?
Plus 7 parentheses k plus 1 parentheses plus 3.
Very good. So I have to, this is my, remember this is the nth term, and I need the k plus first term, so I'm going to replace that n with a k plus 1. That'll get me my k plus first term. In other words, the next term.
Wait, so where does the other side go? The k, 7k plus 13 over 2.
We have to get there.
Okay.
We didn't start with that. We have to end there. That's why it says prove that. I can start with one side or the other. And I'm going to give you the hint. You never start with the right-hand side. You'll never manipulate this to get backwards to this. That just won't happen.
Okay.
So now we have to realize, just like we did last time, it's the same setup. That is s sub k plus 7k plus 1 plus 3. And I'm going to have to start back up here at the top, so I'm going to erase line 1, because line 1 is pretty much done at this point. So then I'm going to come back up here. So s sub k, we already know what s sub k is. We're going to use our assumption line. That's the whole point of that assumption line again.
Oh.
And so we get k, 7k plus 13 over 2 plus 7k plus 1 plus 3. So I replaced my s sub k here with what we assumed in line 2, and I get my new line. Does everybody see how I did that? Everybody okay with that? Okay. So now this does become a little bit difficult for algebraic reasons, but I need to combine this all into one fraction, as we're seeing here. The easiest way to do that is to get a common denominator. So what I'm going to do is I'm going to put this over 1, and then get a common denominator. So I'm going to multiply both the top and the bottom by 2. So this is going to become k 7k plus 13 over 2 plus 14k plus 1 plus 3 over 2. Does everybody see how I did that and okay with me doing that?
What if you already simplified the 7k plus 1 plus 3? Will it still work?
That's fine. You just multiply it by 2, yeah. Oh,
Okay.
plus, ooh, careful. I made a mistake. Careful. K plus 6. Don't be a baddie like me. I'm going to get rid of line 2 now because I need a little more room. At this point, it's just algebra of combining and then making it look like this. Now, it's not the easiest thing in the world. I'm not going to lie to you. I'm going to do some distributions and things like that. So it's not the necessarily easiest thing algebraically, but it's just algebra at this point. If you get to here, this is over 90% of the problem. And if you can't really make it to the final part, it's unfortunate, but it's not the end of the world. So 7k squared plus 13k plus 14k plus 14 plus 6 all over 2. Now the very nice thing about that, we know what it factors into, so you can kind of make some jumps and leaps that you're usually not allowed to do. So 7k squared plus 27k plus 20. I know it has to factor into this, so I know it's equal to k plus 1. Now I'm not going to jump directly to this line. This would be 7k. Did I do my math right? Hold on. Oh yeah, that's right, 7k plus 20. Plus 20. All over 2. Now, notice, I didn't have to actually factor that. I didn't do any work, didn't figure anything out, because I know it had to factor into k plus 1, and this would be 7k plus 20. Does everybody see how I figured that out without actually doing any factoring? Gonna hope by the silence that means yes.
Wait. No. Why is it 20?
Because if I multiplied this out, this would be 7 times
Oh.
k plus 7 plus 13. The 7 and 13 would make a 20.
Okay. Okay.
So just by virtue of me knowing what has to happen. And then I'm not going to lie, at this point, I just write the answer. This is all algebra requires. I mean, if they're really going to make you do more than that. And done. I don't think it's going to be quite that algebra intensive, to be honest. And there may be an easier way of doing it that I just didn't see. I'm not going to lie. I don't think it's going to be quite this algebra intensive on the problem.
Wait, so now do you just subtract 7 now?
No, you're done.
No, but how did you go from 20 to 13?
Oh, yeah, you technically need to make it 7k plus 7 plus 13. And then factor out a 7 out of here, giving it the k plus 1, and then plus 13.
Okay, but we just skip that step.
Yeah, I mean, at this point, like I said, this is where you get to take some what we call leeways, because you know what it's going to turn into. So at this point, I know this is going to turn into this, so I can just write it, and they can't really question it necessarily, because they can't say, "Oh, you didn't know." I'll be like, "Oh, well, I just knew that's what it turned into. I knew they were the same thing," so they can't really question it. Again, I really don't think the problem you're going to have to do is going to be this algebra intensive. This took quite a few lines. Now, I'm not going to lie, it may end up being that. I just don't think it would. I personally wouldn't think it would do this. But really, it's just a bunch of algebra manipulations. So if you get to here, like this area where I'm in the middle of it, which is close to the end of the actual math, you would be getting 90% of those points, to be honest. It's the extra 10%. So like if it's 5 points, you would have got 4 out of the 5 for that, for instance, something like that. But that extra last little point is for the algebra. If they give you a problem this mathematically intensive, I don't think it'll be quite that hard. Anybody have any questions on what I did anywhere? Specifically steps 1 through 3. The algebra, understandably, there's some hiccups in there for most of you. Does anybody have any questions on the algebra that I did? Or I mean, the steps, not the algebra. Brain fart. Okay. Only about 5 minutes left. We probably don't have the time to do a full another one. So I will set another one up, but not finish the algebra on it. Somebody pick another number, and it could be anything through 25. I mean, we can do any of the problems. It doesn't really matter.
25.
Okay. Is it less than or equal to? Yeah, okay. So they want you to prove that 2n is less than or equal to 2 to the n. All right, step 1. What do I do?
See if n equals 1 is true.
So plug in n equals 1. So step 1 is 2 times 1 less than or equal to 2 to the first. 2 less than or equal to 2. Check. So 2 is equal to 2, so that works. Somebody besides Miss Madison. Step number 2. Anybody, step number 2.
Isn't that just replacing all the
Assume
n's
n
with
equals
k's?
k.
So very important, you have to have that word in there. You have to assume. If you did not put the word assume, I would definitely, personally, I would take off points. Because the whole point is this is an assumption that you're making. Okay? And then step 3. What is step 3?
Prove it.
Prove 2k sub k plus 1 is less than or equal to 2k plus 1.
So I'm going to take a little bit of liberty with what you said, but yes, Mr. Harrison, very good.
Sorry, I struggled with the exponents and sub thing.
That's fine. That's why I took a little bit of liberty, but what you said was on the right track, yes. So we're going to prove that the k plus first. So step 1, plug in 1. Step 2, assume and plug in k. Step 3, plug in k plus 1, and that's where you got to go. So now we have to somehow get from here back to here. There's all kinds of different ways that we can get this. So you're going to do some algebraic manipulation. Now some of these become a little difficult. I might have time to finish this one. This one's not too bad. So first thing I realize is that over here, yeah, so I can make this 2k plus 2 possibly. This is less than or equal to 2k times 2. Possibly something I could do there.
Then do you divide both sides by 2?
No, I'm not going to do that because that won't get me back to here. Because that would get me to k plus 1 is less than 2 to the k. Which is a true statement, but it doesn't use my assumption. So let's see, how am I going to do
So
this?
what are you trying to make it be?
You're trying to get back to here, kind of. You're trying to use this somehow.
I can't see this term.
Sorry, you're trying to use the assumption line. My bad. I'm sorry.
Okay.
Let's see. So what am I going to do?
It's just like 20 seconds delayed.
Let's see. So let's see what happens if I do this. So 2k less than or equal to 2k times 2 minus 2. So 2 times, not 2k, 2 to the k. To the k minus 1. Let's see, how am I going to do this one? So I could do it, but it's not using our assumption line. Let's see how the book does it, because I'm sure there's probably an easier way. But do they even use the assumption line? What do they do?
Wait, how did you know?
How'd I
How
know
did
what?
you get from 2k times 2 minus 2 to that?
I factored a 2 out on both sides, or on the right side, out of both. So you get
Okay.
2k minus 1 left.
Couldn't you just do on the right side, the second to last line that you did? 2k times 2 minus 2. No, never mind.
Hold on. So let's see. So we're going to do. I'm gonna try something. Hold on. So you get. Listen to. Do that. I don't think that gets me anywhere. So let's see. In this case, we could start with the original. And multiply both sides by 2. Then I get. I get what I want on the right hand side. I don't get what I want on the left hand side. Oh, this is a nasty problem. This is terrible. I would never expect you guys to do it this way.
Does it like show the work in the book?
It does. I just don't like their methods. I'm trying to figure out a different one. So basically what they end up doing is they end up making this, so they multiply both sides by 2, and they get that this is 4k is less than 2k plus 1. But then they make the statement that 4k is less than, I don't know if it's or equal to, we can put or equal to, doesn't really matter. Then, so k plus k, so 4k is equal to k plus k, which is less than k plus 1 plus 1, which is less than or equal to 2k plus 2, which is equal
Wait.
to 2k plus 1. So they use this whole idea over here on the right, which I would never expect pre-calc students to do that. I don't like this problem. It's a terrible problem. So basically they multiply both sides by 2. They get to this.
Wait,
What?
how did they get to 2 times 2k on the left side? It's 2k plus 2, I thought.
Where?
Right underneath the prove statement. It goes from 2
Yeah, so
parentheses k plus 1 to 2 times 2k.
no, this is what I'm trying to prove. I'm trying to get here. I started with my assumption line. So this line right here is the assumption line. I multiplied both sides by 2. So the right-hand side turns into 2k plus 1, like I want it to. Now I need to manipulate the left-hand side to turn into this like I want it to. Which I don't like how they do it, because I don't expect pre-calc students to be able to do that. So basically what they're saying is they're saying that 4k is less than or equal to 2k plus 1, which is then less than 2 to the k plus 1. So this is what they do. So you get this statement here, which has to be true as well. I don't like how they do that. Not for pre-calc students. If this was like a higher level, I'd be okay with that. But for pre-calc students, I really don't like that. No. So sometimes you start with the assumption, which is in this case. Sometimes you start with the prove line. Like if I could have started with 2k plus 1 and got to where I needed to, then fine. Which you can do, but it's not really mathematical induction. And this I wouldn't call this mathematical induction either. This is very, very off the beat for mathematical induction, so I wouldn't expect to see anything like this, to be honest. Other problems, yes, perfectly fine, but not like this. This is just terrible. Yeah, so for questions like number 25, you start with your assumption line. For the series, you can start with the other lines and use your assumption, which is really what PMI is used for. PMI is used for like your summations and things like that. It's not used very often for 21 through 25. I would never use those for that. I would use many other ways of doing that, not mathematical induction. So 21 through 25 can be a little difficult. You have to do things like multiply both sides, add stuff to both sides, and things like that. But so for numbers like 21 through 25, I will tell you that yes, you start with your assumption line.
So, on the right-hand side,
Mm-hmm.
you go from k plus k plus k plus k to k plus k plus 1 plus 1?
Yes.
How?
Because see the sign in between them?
Oh, that's like the same line.
That's a less than or equal to thing.
Okay.
So 4k is equal to k plus k plus k plus k.
Yes.
We know that is less than or equal to, or sorry, greater than. I
Yeah.
used the wrong sign, not paying attention there.
Yeah. Oh.
Greater than or equal to, my bad. I used the wrong sign, I wasn't paying attention.
So how
So
are we supposed to know that?
that's why I don't like this problem for pre-calc students.
Oh.
I would
Okay.
not expect you guys to make those jumps. That's what I'm saying. So I don't like this problem at all for a
Okay.
pre-calc student. This is something that I would expect of a higher level student, or even maybe when you're undergraduate level mathematics, not a pre-calc student in high school, or even a pre-calc student in college, to be honest. But this is something I would expect in a undergraduate level math course where you're doing mathematics, not a pre-calc course, because pre-calc is not really a college level course, not math. So I don't like that problem for that reason, because you would have to make this jump here. And making this jump here is not something I would expect of, like I said, you'd have to be doing pretty decent in your undergraduate level math to make that jump, or be used to doing it. And it's not something you've ever seen before, so that's why I don't like this problem. Honestly, in my opinion, this is a very bad problem to give a high school student, or a pre-calc student in general. But yeah, like I said, as you're looking through all this stuff, numbers 21 through 25, those types of problems, those you will start with your assumption and manipulate your assumption to get to your new thing.
Do you think this will be on the test? Like weird problems like that?
I want to say no, but also at the same time, I feel like I would probably put one on there. I would also probably give you a hint if I was going to do that, though, of things to use, like the right-hand side. I would have gave you that or something like that idea. But an easy one, yes. A more difficult one, like number 25, no. So something where you just have to like add one to both sides or something like that to get it, or multiply both sides by 2 and then you have it, yes. Something requiring the jump on the right, no, I would never give you anything like that. So let's see if there's a relatively easy one. Yeah, no, they're doing pretty much the same thing on all these problems. These are all pain in the butt problems. That's terrible. I personally I wouldn't give you anything like this, no. Do I think there could be one on there like that? I wish I could tell you, but I would want to say no, but I don't want to say no and then there end up being one, so I can't say for sure. My inclination would be that no, there's not one. I would venture to say the quiz is probably more of a pain in the butt problem, and if it is, ask for help. If it's not, I don't see it being on the test, though, to be honest. I don't think they would put one like this on the test. Very few people would get this right, to be honest. So I would see something more along the lines of your mathematical induction question being one of the other ones that we actually do mathematical induction with, where it requires algebra and stuff like that. Now the quiz, though, the quiz may end up being a pain in the butt problem. I don't know. I haven't seen the quiz. If the quiz is a pain in the butt problem, just ask for some help, please. I didn't say that, but please ask for some help. All right. Okay. Then we went over.